Hello everyone, welcome to today's video tutorial. In this tutorial, we will be learning how to create a SDL2 window that can also react to some user inputs. So we will be closing the window when we press the S key or when we click on the close button here at the top left. We will be also going through some basic steps that will allow us later on to build more complex applications. So this will be the first step in our learning journey, let's say. Without further ado, let's get started. Okay, so let's open up VSCode and start coding our SDL2 window. We will be using the SDL2 starter project as usual. You can find the link to the GitHub project in the description down below. The first thing we will do is to set up our graphics configuration. Let's start by defining the width and height of our window. This window will have a width of 512 pixels by a height of 284. Let's also declare our SDL window and our SDL handler. Those will be pointers that we will be using further down in the code. Now let's define the colors that we'll be using in this application. We will be only using the color black. So let's declare a namespace colors where we will declare this black color using the SDL color type. So we will declare a const SDL color. We will name it black, and then for the red, green, and blue components, they will all be 0, as this is the black color. And the alpha transparency, we will be using alpha opaque. The next step will be for us to declare our initialization function, where we will be actually creating the window and the renderer as well. So let's start declaring our static boolean init function. We will just copy this part here from the main function here. This will not change, so we will leave it as it is right now. So that's just the SDL initialization, the SDL system initialization. Now let's start creating our window. So we will assign to the main window handle the output of the SDL create window function. This function takes some arguments. The first argument is a string that will be used for the Windows title. So we will be using here SDL create window, and then let's just add the size of the size of the window here as a reference. 512 by 284. And then the next two arguments, they will define the position of the window on the screen. So we will be centering the window. And for that, we can use the SDL WinPause centered for these two arguments. And finally, we will define the window width and height. And that's it for the creation of the window. Oh, I forgot about this last step here. So we will be setting this SDL window OpenGL as the context for this window, because we will need an OpenGL context later on to draw things on top of it. Now let's check if the creation of the window succeed. We can do that by checking if the handle is has something different than the no pointer address. And if that's the case, if there was some error during this creation, we can get access to the error by using the SDL get error function and log the error to the console so we know what happened. So let's do that here. We can get SDL get error to have access to the error and just append an end line to this debug line here. Okay, moving on, we can quit the SDL system here. If we cannot create a window, we cannot do much, so we will be essentially ending our application here by exiting with the failure status. All right. Next step is to create the renderer. If we have a window successfully created, it's very unlikely that the render will fail, so we will just access the SDL create renderer function, passing as a reference the recently created window. We will not specify any index for the renderer. We will let SDL define that for us, and as per the flags, we will just instruct SDL to cap the frame rate automatically for us using this renderer present vsync, sorry. All right, and now we can return true, indicating that our initialization was successful and everything went okay. And that's our initialization function. The next function we'll be creating is a shutdown function. The shutdown function will essentially destroy the window we created, the renderer we created, and all the allocated resources, and will also clean up all the objects created by SDL itself by calling at the end the SDL quit function. This way we don't leave any of those objects occupying our computer's memory once we close the application. So we check first if our main window has something assigned to it, and if that's the case, then we ask SDL to destroy the window, passing the window handle as a reference, and we assign the null pointer to our main window to free the memory. We do a similar process for the renderer, so we check if we have a renderer assigned, and if that's the case, we ask SDL to destroy the renderer, and we also assign the null pointer to the renderer handle to free that particular memory space. And finally, we call SDL quit to shut down all the SDL internal systems and allocated objects, and that's all for our shutdown function. So next we will create a helper function that will clear our renderer. Clearing the renderer is essentially erasing everything that you have on the renderer and painting it all the pixels, or painting all the pixels with a predefined color. So that's what we will be doing here. This will be running every frame before we actually draw a new state to the renderer. So let's create a function clear screen, which will take a renderer as reference. The first step here is to set the color that we want the renderer to use. In this case, we will use the color black that we defined previously. So we will call SDL set renderer draw color. Then we will pass our renderer as a reference, and we will access our color black, red, green, blue, and alpha values, and we will pass them on here to this function. let's access color black, blue, and finally colors black alpha. Alright, now that we define the color that we want the renderer to use, we will instruct the renderer to clear itself by calling the SDL renderer clear function, passing as a reference our renderer, and this will paint essentially all the pixels with the black color. So we have a blank canvas to start drawing things on top of it. Now let's go to the main function and the main loop. We are almost there, so let's put all these pieces together now. So let's remove this code here that we will not need anymore, and let's start calling our init function. If the initialization succeeds, we will proceed, otherwise we will call our shutdown function and terminate the application. So if init equals true, actually equals false, sorry, then we shut down everything, and this will exit our application and will release everything that was allocated. If the initialization succeeded, then we will start our drawing loop, let's say the main loop of the application. For that, we will need an SDL event variable where we'll be reading events from the SDL and assigning those events to this variable here. And we need a Boolean flag to indicate if the application is still running or not. Now we start our main loop. While the application is running, we will do something. This something is to check for SDL events. So we first clear the screen, as I said, so that's the first thing we want to do actually at every frame. And now it's the time where we'll check for user inputs and process them accordingly. Okay, so check and process IO events. So here we will pull SDL events using the SDL pull event function, passing the address of our event variable. So if there is any event in the SDL queue, this event will be assigned to our event variable, and then we can have access to it. If that's the case, then let's see, or let's evaluate which event it's that. So we will evaluate the event type, and in case this event type is an SDL key down, the user pressed a key, we want to check if this key is the ask key. If that's the case, we want to stop running the application, right? So running equals event key. Then we can use this structure here, event key, key sim scan code. So this will give access to the SDL scan code that corresponds to the key that the user pressed. And we want to check if that's not equal to ask, because if that's equal to the escape key, then we want to stop running the application. And then we break this check here. We also want to check if the SDL quit event was emitted. This will be an event emitted when we click on the closing button of the window. If that's the case, we will also say that we want to stop the application from running, so we set running to false. And if there is any other event, then we will just ignore this event, because we are not interested in any other event other than these two here at the top. So that's it in terms of listening and handling events for the purpose of our application. Okay. Now that we checked for the events, we will update the screen with the content that we have on our renderer. Right now, the renderer is fully black, so there's nothing drawn on top of it, but in future tutorials we will be drawing geometries, squares, circles, etc. to this renderer, and then this will be presented to the user. We use that using the SDL render present function and passing the renderer as a reference. The renderer has a back buffer where we'll be drawing temporarily the new state, and when we are ready, this back buffer is flipped to a front buffer, which is the one that the user actually sees. And finally, we shut down once the application it's not running anymore. We shut down the systems and we exit the application successfully. Now let's make our application and see if it works. We will use the make command. Now let's test our application. Let's run it and try to close it by clicking on the close button at the top left corner of the window and see if that works. So here we have our window. Let's click on the close button and see what happens. Okay, it closed successfully. That's what we were expecting. Now let's try the ESC key. So let's press the ESC key and see if it closes. There you go. So that's our application for today. I hope you enjoyed. Next time we will be creating or building other applications on top of this one. That's it. Happy coding!